Hello guys, this is Sifar. Today my discussion topic is the compass error by sun. This you must need on board your ship also when you go for the exam, that time also you need. So guys, watch the video and learn the process and you can explain this to the examiner. So examiner will be very happy. So let's watch. Also subscribe my channel. Guys, for doing the compass error by sun, you need the date, you need the position, GMT time, gyro heading, gyro bearing, compositing. So let's take it very quickly. Guys, you take your position from the GPS, you take your GMT from your chronometer, gyro heading from gyro compass. Guys, take your compass heading from your magnetic compass. Now guys, you will go to the port side bridge wing and take the bearing for the sun. Guys, one more very important thing I want to add here. When you take the bearing, you see on your compass card you see 150, 51, 52, 53 like that. So when you take the bearing 154.5 or 154 or 155 like that way, or 155.5 or 156 like that way you take the bearing. Okay, not like that 154.1, 154.2, not like that. So guys, remember this one, 154.5 or 155 like that way you take the bearing. Okay guys. Okay guys, on my gyro repeater I have the azimuth mirror. By azimuth mirror I am taking the gyro bearing. As you see, this is the mirror and this mirror will reflect the sun on this side. So if you see from this side, you see a narrow beam of light on your compass card. So my gyro bearing is 154.5. as you see, I already write all my value. So guys, now I'll go further. And one thing I want to tell you that gyro bearing I write in the pencil. I'll tell you why I write in pencil, because maybe at the end I need to adjust the gyro bearing. Guys, you see I will write my sequence. This sequence also you can memorize. It's a very important sequence. You should need it. And guys, now I'll go for the nautical almanac and find my GHA value, increment value, declination, decorrection value from my daily page and increment table. So let's go there. Guys, from the nautical almanac page, I have the electronic means e-nautical publication. Maybe you have that hard copy also, doesn't matter, same things. Come for the daily page. 24 November. You see, I little bit show it from up. See, this is November 24 date. This was okay. This is 24 date. This is the GMT. This is your JJ. This is your declination. Okay, guys. So take the value from here, and if you scroll down a little bit, at the end you have the D value. So you need this D value also. The value from daily page. Now we'll come for the increment table. See, I have the minute, 6 minutes 10 seconds. So for this I need the increment value and the correction value. So as per my 6 minute 10 second, my increment value is this one, and my decorrection 0.5. For 0.5 my decorrection value is 0.1. see this one. So let's take the value. Guys, I already import my value. You see GHA, increment, declination, decorrection value. You see guys, one more thing, increment is always plus with the GHA and declination can be plus minus, because of on my daily page my declination is increasing, downwards increasing, so that's why decorrection is plus. So you should remember this one also. If downwards is decreasing, that is minus. You just watch on your daily page. Okay guys. As if you see guys, my GHA I add with increment, I find the final GHA, and after that longitude is east, so I add, so I found my LHA, and with the LHA I subtract from 360 degree, I found the P value, just to avoid the minus sign. Remember this one guys. If your LHA is more than 180 degree, you can subtract from 360 degree and find your P value. So guys, I find my P value just to avoid the minus sign when I will calculate for A and B. Remember this one guys. And your declination and decorrection, so I find my final declination. So now go for the A and B calculation. Guys, for doing the A and B calculation, you can use this formula. A is equal to 10 led by 10p, B is equal to 10 declination by sin p. You can use this formula and you can find your A and B value. Always you can find A and B value from your Norris nautical table. This on your A table you can find A value, B table you can find your B value. You see, A table is against latitude and LHA, B table is against declination and LHA. So you can find this one also. Just make the interpolation and you can find this one. As I already calculated A value and B value, you should remember one more thing, that you should take 5 figure after the decimal. Remember this one, 5 figure. And the south and south name, how it's come. A and B name south and south, how it comes. Guys, you should know that your A value is south, how it comes. Your latitude is north name. So normally A value is opposite of latitude, except LHA is between 92 to 70 degree. Since my LHA is more than 270 degree, so my A name should be or must be more opposite of latitude, so it's south. And B name same as your declination name. See, your declination is south, so B is south. So it's simple things. And guys, since the A and B is the same name, so add. If it is different name, subtract. You find your C value, and name is same, so south. Remember this one, guys. Yes, now I'll go for the calculation of azimuth. Guys, you can do this calculation by this formula also. Tan azimuth is equal to 1 by C into cos lat. Guys, I already found my azimuth value by using this formula. So azimuth is, you see, 24.3 degree. Suffix is south, prefix is east. How it comes? You should know this one also, guys. Normally this south came, suffix name south came from the C name. Remember this one. And prefix east came because of, you see, your LHA is more than 180 degree. Remember guys, if your LHA is 0 to 180 degree, then this prefix is west. If LHA is 180 to 360 degree, then its prefix is east. Remember this one, guys. This is very important. Guys, also you can find the manual calculation also from your Norris numerical table, table C. You can find here also against the latitude, and C value is here, and you can find your azimuth also by doing the interpolation. This is also you should know, guys. As you see, guys, normally you can find this azimuth from the formula, but you should know the basic also from book how to find. Guys, now from azimuth you should find the true value, true bearing. It's true bearing by the quadrant. As you see, guys, this quadrant I am showing you here. You see, this is north, south, east, west, 4 quadrant. Your value is south 24.3 degree east. So from south it is eastwards. This one is 24.3. This one, okay, guys. So I need to find the true bearing. So true bearing is always from the true north. Remember, guys, always from the true north. So this is your true bearing. Remember, this is your true bearing. So you just subtract from 180 degree and subtract 24.3. Then you can find your true bearing. Guys, after subtracting from 180 degree, I found my true bearing is 155.7 degree true. Guys, now if I find my gyro bearing here, I find my gyro error. But you see, my gyro bearing is 154.5. This is the actual bearing. But my true bearing is this one. How much difference? Difference is little more. 0.5 and 7 means around 1.2 degree difference. This I cannot keep because of, as per my company estimates also normally also we know that gyro error should not be more than 0.5. Because of this is also an observation. If inspector check it, then this is also a big problem. So gyro error should be limited. So that's why I first time I said it, this one I write in the pencil. So now I will correct it and I will adjust it, and I will make my gyro error within 0.5 degree. So guys, you see, I write my gyro bearing 156. Gyro bearing 156 degree gyro, and now gyro error is 0.3 degree high because of my gyro bearing is higher than the true bearing. That's why high. If gyro bearing is lower, then the gyro error is low. Remember this one, guys. Because you see, I adjusted because of I should not keep my gyro error more than 0.5 degree. You should also make this one, guys, and that's why you should write gyro bearing in pencil so that you can adjust it after that. Okay, guys. Remember this one is very important, guys. Because now I will find my variation from my chart or from my ENC like this. No problem. Yes, now you can find your variation from your like this. just right click S57 on about my position. On my position, you see magnetic variation. This 2015 it was 7 degree west, and yearly change is for 4 minute west. So from this 2024 is 9 year, so 7.6 degree west my variation value. So guys, you should know this one, how to find this variation. Guys, remember one more very important thing is that on your compass deviation book you should have a deviation table. Remember this one, this is very important, and you can check as per your compass heading how should be your deviation. This also you should put in a limit. Remember this, guys. Guys, you should know that this deviation is a calculated deviation, and deviation from your deviation table. As per my company policy, that difference should not be more than 3 degree. So you can follow your company policy also, but I don't keep 3 degree difference, I keep more or less also. So just if you follow your company policy also, no problem. So just check your company policy, what they want the difference, how much they want the maximum difference, so you can follow that one also. Now guys, you see you got your gyro bearing, but you don't get your compass bearing, but you have the gyro heading and you have the compass heading. The gyro heading and compass heading differences, you see how much? 7 degree. So if it is 7 degree difference, so your gyro bearing is this one, so your compass bearing also will be 7 degree. Since the compass heading is more than gyro heading, 7 degree more, so your compass bearing will be 7 degree more than your gyro bearing. Guys, if you see here is your gyro heading and compass heading difference is 7 degree, so I put my gyro bearing and compass bearing difference is also 7 degree. Okay guys, because you cannot take the bearing by the magnetic compass, so just take the bearing by the gyro compass, and after that from reference from the gyro bearing you can find the compass bearing. Now guys, remember this compass bearing is more, true bearing is less. So if the compass best, error west, compass least, error east. Compass best means compass is more, least means less. So since the compass bearing is more, so your compass error will be west. Just subtract and value name will be west. Guys, for understanding this one, how to find the deviation, you see, you should know that how this deviation, variation and compass error came. Guys, you should know that between your true bearing and compass bearing is your compass error, remember, and magnetic bearing and true bearing is the variation. This is the variation, you see, and compass and magnet in between is the deviation. So guys, if you draw a line, this is a true bearing, draw the true north, and you see you first apply your compass error. Okay, compass error is between true bearing and compass bearing, so it is west, so from true to west, so this is your compass error. Okay, this is your compass error up to the compass bearing. Now if you come for the variation is between the true and magnet, so true and magnet is 7.6 degree west. If it is west, so it's more west, correct, because compass error was 7.3 and variation was 7.6, so this variation will be more west. So from true bearing to the magnetic bearing, more west than the compass bearing, so this is your variation. Okay guys, this is your variation. Now you find the deviation. As you see, deviation is in between the compass and magnet, so this compass bearing and the magnetic bearing is the deviation, so this is your deviation towards the east, so difference is 0.3 degree east. This is your deviation. You should know this basic, guys. See guys, I already finished my compass error, all finished. You see, deviation also finished. My this deviation also is nearly little bit difference with my deviation cards, is okay within the limits, and my gyro also within the limits, that means is okay. Now I will input all the data to my compass error book. Guys, and finally I am coming for the compass deviation book. Here I fill up as per my date UTC, I fill up all my data. You see, I fill up all my data, and at the end I make the signature. So guys, this you must know, you have to do in every watch once, and after every alteration, of course, means every big alteration, of course, you have to make. So guys, that's all for today. Thank you too much. Bye bye.